Okay, the unit circle is a big subject in trig to take on, so we're going to try and break it down for you a little bit at a time. We're going to begin by drawing a regular circle in the coordinate plane that has a radius of 1. So that means that this point right here would have to be the point 1, comma 0. Of course, this is your x-axis. Of course, this is your y-axis. So far, so good. Okay, so we're going to write down a couple of key things about this unit circle as we go along. Okay, first thing to note is that the unit circle is a circle with a radius of 1. So that means any point along the circle, if I draw like this point right here, and I draw a line to it, what's the distance from the center to that point? What's it going to be? It's going to be 1 unit. Okay, so keep that in mind. So that's 1. All right, good. The other thing I just said, the center of this circle is located where? At the origin. Yep, at the origin of my coordinate plane. Okay, so the center is located at the origin of the coordinate plane. All right, so far so good, right? If I'm dealing with radians, that means this is 1 over here too. So if I'm dealing with radian measure, then I would have swept out an angle right here. This is going to be my central angle, call it in purple. I'm going to call that angle T, a central angle of angle T. And if I have swept out a central angle T, then I have also swept out or subtended this length along the arc, and we always call that length a length of S, right? You guys okay with that so far? Call it S. Good. Okay. Okay. This point, I'm going to consider this point, I'm going to call this point P. All right? So at point P, right, how would I get to point P if I'm in the plane? Just generically speaking, how do I get to this point over here? Well, if I were to draw a little triangle here, how would I get over to that point P? I would go over in which direction? Right, in the x direction, and then I would go up how much? I would go up some y direction. So every single point on this unit circle can be represented by a coordinate point in the plane, namely x and y. Does that make sense to you so far? What's going on here? So this triangle that I have drawn sort of inside my circle here can be represented or drawn anywhere in the unit circle, right? And the point that's always corresponding can be represented by an x and a y that comes from the triangle drawn from inside. You guys good with this part? Okay, now let's remember, if we're dealing with radians, we know that this relationship is true. We know that S is equal to R times theta. That's the arc length distance formula, right? Okay, so S in this case is, what's my radius in my unit circle? Yeah, the unit circle, the radius is 1, and theta I have replaced with T. So we have this very, very powerful statement that says S is equal to T. All right, what does that actually mean? That means that the arc length is actually equal to the radian measure of the central angle. All right, this is a powerful statement, and it says that this arc length is equal to the radian measure of my central angle. And notice that that angle is the same angle that's in the triangle that I've drawn to create point P. So there are 3 things going on here. There is the point P, which is x and y. There is an arc length S, which we've now realized is the same as that central angle T. And that central angle T is the same angle in the triangle that represents x and y. Do you guys get with that part so far? All right. Okay, so I'm going to start off by talking about the 6 trig functions, and we're going to keep in mind this triangle, and this triangle is basically representative of this triangle that you have in this picture up here, this one, where the radius is 1, so my hypotenuse is going to be a measure of 1. All right? There are 6 trig functions, and I'm going to give you the name of the trig function. Then I'm going to tell you the abbreviation for the name, which is the longest word ever. And then I'm going to give you the actual unit, right, circle value. Okay, I'm going to give you the name, the abbreviation, and the unit circle value, and there are 6 of these. So the first one is going to be this. It is called the sine function, and I know that you've heard the sine function before because you've all taken geometry, right? What's the abbreviation for the sine function? Yeah, SIN. Please do not say sin, right? We're not going to say the sin of an angle. So, the sine of angle T. Now take a look at this picture I've drawn on the unit circle. Remember, our unit circle is a hypotenuse of 1. So the sine is defined as what over what? Opposite over the hypotenuse. So in this case, it would be y divided by what? 1. So y divided by 1 is just what? Y. Very good. So the sine of t is just equal to y. Okay? Oh, so far so good. All right, number 2. The cosine. What's the abbreviation for cosine? Yeah, please don't say cos or cos or anything like that. Actually say cosine. All right? And in the unit circle, the cosine of angle T is defined to be the adjacent over the hypotenuse, which is just x. Good. So we're getting some good information on how to relate x and y to trig functions, sine and cosine. All right? Move up a little bit here. The third one is tangent. Okay? The abbreviation for tangent is tan, T-A-N, yeah, tangent. And the definition for the unit circle? The tangent of angle T is defined to be y divided by x as long as x is not what value, everybody? Okay, if it is x, if x equals 0, we call that undefined. All right? So there are some angles out there for which the trig function is not defined because we can't draw a triangle to make it work for ourselves, okay? Okay, there are 3 more. 4, 5, and then 6. Okay? We're going to go with cotangent. Okay? Cotangent is not, sometimes books call that arctan, but in our book just calls it cotangent. So the abbreviation is going to be COT. Please don't say cot. It's cotangent. And then the cotangent of angle T is going to be defined as x over y, provided that y does not equal 0. If it is, we call it undefined. Do you guys notice anything about these two values? One's y over x and one is x over y. Is that considered opposite? No, what's the opposite of 5? Negative 5. So it has nothing to do with sign change. What do we have here? We have reciprocals. Yeah, inverses. We have reciprocals. So one is y over x, one of them is x over y. All right, that's cool. Let's keep going. Keep that in mind. So the next one we have is secant. Okay, what's the abbreviation for secant? SEC. And in the unit circle, the secant of angle T is going to be defined as 1 divided by x, provided that x is not 0. If it is, we call it undefined. What's that the reciprocal of? Oh, look at that. So there's a relationship. I'll bet you can guess the last one, right? You see where this is going. You're seeing the pattern here, right? The last one, the word for it is cosecant. And the abbreviation is CSC. And the cosecant of angle T, Lauren, what's your guess?
1 over y.
Is 1 over y, provided that y is not 0. If it is, we call it undefined. And you're absolutely right. You're recognizing that it is the reciprocal of the sine function. So here they all are, start to finish. Okay, so how does this all fit together? So let's say we have a unit circle drawn here. All right. And let's say there is a point on the unit circle P over here in quadrant 3. That point is defined as -3/5, comma, -4/5. And we have swept out an angle of T, right? And I want you to keep in mind that we could draw a right triangle here, and we could draw a little tiny angle inside there, all right? Now remember that this angle here is corresponding to that angle there, right? And P corresponds to that same angle that we've drawn. So you're gonna see directions say something like this. So P is a point on the unit circle. So I'll put UC for unit circle. That corresponds to t. All right? So P is a point on the unit circle, which means that the hypotenuse is 1. That corresponds to t. So that means that this distance had to be 3/5 and this distance had to be 4/5. See how that works? Okay? So now this is the x value, this is the y value. So now I can definitively say the sine of angle t is negative 4/5. It is the y value. See that? Because right here, we figured out that the sine of t is equal to y. So if I'm given a point on the unit circle, the sine of t is the y value. What's the cosine of t? Very good, negative 3/5. It's this value, it's the x value. See it? So that's where we're going with all this information. So here we go. P is the point, negative 1/2 comma rad 3 over 2, and that's a point on the unit circle. We want to find all 6 trig functions at that point t. Remember, P corresponds to t. All right, perfect. So the first thing that I want you to do for all of these problems is I want you to draw yourself a picture. All right? Where is that point P? Here's my unit circle. I didn't do a very good job here. There's my unit circle. What quadrant is P in? If it's at negative 1/2 comma rad 3 over 2, what quadrant does it have to be in? It has to be in quadrant 2. So it has to be somewhere over here, right? So here's my point, negative 1/2 comma rad 3 over 2 has to be somewhere in quadrant 2. Right? So there's my angle T that's been drawn out. If you draw the triangle inside, you have a corresponding angle for the triangle that corresponds to angle T. Okay? This is the x value, this is the y value. You guys get that part so far? It's cool. So we want to find all 6 trig functions. So we want to find this. We want the sine of t, that's going to be something. We have the cosine of t, that's going to be something. We have the tangent of t, that's going to be something. So I want you to write these 3 in a row next to each other on the top. And then right below them, I want you to write cotangent of t, secant of t, and the cosecant of t. Why do you think I want you to write them in this way? There's a reason for it. What's the relationship between tangent, cotangent, cosine and secant, and sine and cosecant? Yeah, back up here, right? We learned in box number 2 that they're all reciprocals of each other, right? So if I set it up like this, and I know one of them, all I have to do is take the reciprocal of the fraction, and I have the other one, okay? All right, well, according to my picture, the x value is negative 1/2. The sine value is rad 3 over 2. All right, the sine value always corresponds to what? X or y? Y. Yeah, defined as here, right? The sine value is always going to be the y. Okay, good. So therefore, the sine of t is what in this case? I'll go in blue for you. The sine of t is rad 3 over 2. Very good. Okay, what's the cosine of t? The cosine of t is negative 1/2. Very good. See how this is going? All right. Now, if I know the sine of t is rad 3 over 2, what's the reciprocal of that? 2 over rad 3, which would be what? Yeah, if you don't know, just say 2 over rad 3. Rationalize the denominator. Rad 3, so it would be just 2 rad 3 over 3. Okay, awesome. If the cosine is negative 1/2, what does the secant have to be? Negative 2. Awesome, very good, negative 2. Okay, how do I get tangent out of this? It's y over x, so it's sine over cosine. Okay, if you don't know, just literally put the sine, rad 3 over 2, divided by the cosine, negative 1/2, and then simplify that. What's that going to be? Negative rad 3. There you go, negative rad 3. Okay, so if the tangent is negative rad 3, what is the cotangent? Yes, negative 1 over rad 3. Rationalize that, becomes negative rad 3 over 3. And you have now found all 6 trig functions that correlate. You have found all 6 trig functions at point T, where T is corresponding to the point P. Here's another example. I'm going to just give you a point P. Okay, here's point P. It's going to be on the unit circle. I'm not going to tell you the coordinates. This is X, this is Y. You have to figure it out. All I am going to tell you, though, is that T, this angle here, t is going to be equal to pi over 4. Okay? T is going to be pi over 4. Pi over 4, though, is a very, very special angle. Do we know that one? That's a 45 degrees. So imagine drawing a triangle with a hypotenuse of 1. Okay, so let's think about this. Let's see here. This is 45 degrees. This is 45 degrees up there. This is 1. So what does this one have to be down here? We did this one earlier today. Rad 2 over 2. What's this one have to be? Rad 2 over 2, right? If you don't know that, you can look at your the triangles that we did at the very beginning of class, that little sheet I handed out to you, okay? All right, good. So now this has to be rad 2 over 2, and this has to be rad 2 over 2. All right, good. So now we have the point P corresponding to T. Easy. Now what we want to do is we want to find all 6 trig functions. So we're going to write down, okay, the sine of, what's the angle we're working with, everybody? Pi over 4 is going to be something. The cosine of pi over 4 is going to be something. The tangent of pi over 4 is going to be something. The cotangent of pi over 4 has to be something. The secant of pi over 4 has to be something. And the cosecant of pi over 4 has to be something. All right, which ones do we know already? The sine of pi over 4 is what? No, what's it? What is it? Yeah, this is your cosine, this is your sine, right? Remember, x and y. So sine of pi over 4 is going to be rad 2 over 2. How about cosine pi over 4? Rad 2 over 2. How about tangent of pi over 4? It's 1. Yeah, remember, it's sine over cosine. It's y over x. So if you don't know, just go rad 2 over 2 divided by rad 2 over 2. It's this one divided by that one. That's what it says right here in the definition, right? It is y divided by x. That's what it says. Okay? So that, of course, is just simply 1. Awesome. Okay, if you know those, you know the bottom, right? What's the cotangent of pi over 4? No, cotangent of pi over 4. There you go. It's just 1. The reciprocal of 1 is 1. Good. Okay. Rad 2 over 2. What's the reciprocal? Yeah, 2 over rad 2. Which is what? Which is just rad 2. Yeah, very good. And this one also be rad 2. All right. Okay, here's the picture. Here's the setup, right? There's a point P on the unit circle. I'm not going to tell you the coordinates of P. You have to figure it out because I'm telling you that the angle T is pi over 6. All right? You are on the unit circle, so that means that this point is 1, 0, and that means the hypotenuse is 1 of that triangle. Okay? So you need to figure out the points and then tell me all 6 trig functions that correspond to T at point P. So here's what I suggest that you guys do to get this right. I would draw a 30, 60, 90 in the same orientation because pi over 6 is 30 degrees. So that's 30, that's my 60 up here. I know my hypotenuse is 1, and the hypotenuse is always twice as much as the shorter side. So this has to be a half, and this has to be rad 3 over 2. So therefore, the point is located rad 3 over 2, comma 1/2. Filling in everything else, you end up with 1/2, 2, rad 3 over 2, 2 rad 3 over 3, rad 3 over 3, and then finally a rad 3. Okay, ladies and gentlemen, I'm giving you the point P, and I'm telling you that point is located at 0, 1. Therefore, that angle is 90 degrees, which is, of course, pi over 2 radians. So I would like you to tell me, give me the sine, pi over 2, cosine, pi over 2, tangent, pi over 2, and all the way down the line. Okay, ladies and gentlemen, here we go. Let's finish up this lesson strong here. The x value is 0, the y value is 1. The x value is the cosine, the y value is the sine. Okay, so therefore, what's the sine of pi over 2? What do you guys come up with? 1. Very good. What's the cosecant of pi over 2? No. Also 1. What's the cosine of pi over 2? 0. What is the secant of pi over 2? Undefined. Very good. What's the tangent of pi over 2? Undefined. Very good, because you can't take 1 divided by 0. Undefined. Okay, what about the cotangent? 0. Very good. All right, please turn your calculators on. Alright, your calculator has two modes in which it can measure angles, and the way that you figure that out, which one it's in, is by pushing this button here. Right? You will see on the third line down that there are two ways of measuring angles, which of course we now know about, radian and degree. Okay? So right now, which mode is my calculator in? It's in radians because that's the one that's blinking, okay? What I want you to do is I want you to put the calculator in degree mode by moving over, highlighting degree, and then you have to push enter to put it in degree mode, okay? Now my calculator is in degree mode.
Mine is in degree mode.
Just look up here, okay? Go down here. On the third one? Yeah, okay. Good, now we got second code, so let's get ourselves out of that. All right, now, here's the deal, okay? If this problem that we just did, pi over 2, is that a radian or a degree? That's a radian. What's the corresponding degree for pi over 2? 90, right? Okay, so we want this. So if we say the sine of 90, and we push enter, of course we're going to get a value of 1. Very cool. If we hit the cosine of 90 degrees, and we push enter, again we get a value of, or not again, but we get a value of 0, just like we are in our problem here, right? Now watch what happens when you push the tangent of 90 degrees. You get this. You get an error. How come? Because it's undefined. Oh, that makes so much sense. I'm so glad this is making sense. Okay, awesome, great. Get yourself back out of this. Clear everything. And punch in sine 90. And then push enter and get us back to this little test here. Sine 90 equals 1, okay? And leave that on your screen just like it is on mine, all right? Okay? Now, I want you to go and change your mode. If you go to mode, and then you go down to radian and put your calculator in radian mode, like I have now. And then hit second quit. And then go back to your screen and punch in sine 90. Why does your calculator give you a much different answer? Yes, you have, in this second line, you've asked the calculator for the sine of 90 radians. Okay? In the first problem, you've asked the calculator for the sine of 90 degrees. Okay? I once took an entire Calc 2 exam in the wrong mode, got a D on the test, and I'm like, I'm never doing that again. Okay? So do not be that person. I'm warning you guys now. Okay? So here's what you do. Yeah. Here's what you gotta do. I was in the wrong mode. If I'm in radian mode, watch this. If I'll ask the calculator for a radian. The corresponding radian measure was what in the problem? What does it say over here? Pi over 2. So if you punch in pi, which is the second caret, divided by 2, now of course you get the right answer, which is back to 1. So here's what you have to remember, ladies and gentlemen. If you are asking the calculator for a degree, you must be in degree mode. If you're asking the calculator to take a radian, you must be in radian mode. If you mix up the two, you don't know what you're at, you're going to be messed up. Here's the way that you check, okay? Always, 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 you can either just go to your mode button and see which one you're at. But if you're on a different calculator, some other calculator out there in the world that doesn't have this same button, here's what you check. You always just push sine 90. If that doesn't equal 1, you are not in degrees. Okay? If that does not equal 1, you're not in degrees. So if I could change my calculator back to a degree mode, push enter, get out of this thing, hit sine of 90, and if that equals 1, then I know I'm in degrees, so therefore I know I'm in degrees. Okay? There you guys go.